Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. In this video, we are going to revise the basic definitions and the statements of the laws and principles in this course. This revision guide is from the book Physics Matter. So let's start. Now we have the chapter number 1. The physical quantity. A physical quantity is a quantity that can be measured. It consists of a numerical magnitude and a unit. Each complete to and fro motion of an object is one oscillation. The period of a simple pendulum is the time taken for one complete oscillation. Chapter number 2. Scalar quantities are physical quantities that have magnitude only. Vector quantities are physical quantities that have both magnitude and direction. Speed is the distance moved per unit time. The formula for the speed is distance traveled divided by the time taken. Velocity is the rate of change of displacement. Velocity is equals to displacement divided by time taken. Acceleration, the acceleration is the rate of change of velocity. Acceleration is change in velocity divided by the time taken. Uniform acceleration is a constant rate of change of velocity. The gradient of a displacement time graph of an object gives the velocity of the object. The gradient of a velocity time graph of an object gives the acceleration of the object. To find displacement, we can calculate the area under a velocity time graph. An object falling through air achieves terminal velocity when its weight is equals to the air resistance against it. Chapter number 3. Newton's first law of motion states that every object will continue in its state of rest or motion, uniform motion, in a straight line unless a resultant force acts on it. Newton's second law of motion states that when a resultant force acts on an object of a constant mass, the object will accelerate in the direction of the resultant force. The product of the mass and acceleration of the object gives the resultant force. F is equals to ma, where F is resultant force, m is the mass of the object, and a is the acceleration of the object. Newton's third law of motion states that if a body A exerts a force FAB on body B, body B will exert an equal and opposite force FBA on body A. Friction is the contact force that opposes or tends to oppose motion between surfaces in contact. Chapter number 4. Mass is the amount of matter in a body. The weight of an object is the gravitational force or gravity acting on it. W is equals to mg, where W is equals to weight, m is equals to mass, g is the gravitational field strength. A gravitational field is a region in which a mass experiences a force due to gravitational attraction. Gravitational field strength, which is represented with the small g, is defined as the gravitational force acting per unit mass. The inertia of an object refers to the reluctance of the object to change its state of rest or motion due to its mass. Density is defined as mass per unit volume. The density is represented with this formula. The rho, this is the alphabet which shows the density. the rho is equals to mass divided by volume, m by v, where rho means density, m stands for the mass of the object, and v stands for the volume of the object. Chapter number 5. The moment of a force or torque is the product of the force and the perpendicular distance from the pivot to the line of action of the force. Moment of the force is equals to F multiplied D, where F is the force and D is the perpendicular distance from the pivot. The principle of moment states that when a body is in equilibrium, the sum of clockwise moments about a pivot is equal to the sum of anti-clockwise moments about the same pivot. The center of gravity of any object is defined as the point through which its whole weight appears to act. The stability of an object is a measure of its ability to return to its original position after it is slightly displaced. Then we have chapter number 6. Chapter number 6. Energy is the capacity to do work. The principle of conservation of energy states that energy cannot be created nor destroyed, but can be converted from one form to another. The total energy in an isolated system is constant. The efficiency of the machine can be calculated using the formula: efficiency is useful energy output divided by the total energy input multiply 100. The work done by a constant force on an object is the product of the force and the distance moved by the object in the direction of the force. W is equals to F multiply S, where W is equals to the work done by a constant force F, and F is equals to the constant force. S is the distance moved by the object in the direction of the force. When a body of mass m moves at a speed v, its kinetic energy is given by the kinetic energy is equals to half mv square, where ek is the kinetic energy, m is the mass of the body, and v is the speed of the body. Gravitational potential energy is given by gravitational potential energy is equals to mgh, where ep is the gravitational potential energy, m is the mass of an object, g is the gravitational field strength, and h is the height above the ground. Power is defined as the rate of the work done or rate of the energy conversion. Power is equals to W by T, and that is equals to E by T, where P is equals to the power, W is equals to the work done, E is equals to the energy converted, and T is equals to the time taken. Chapter number 7. Pressure is defined as the force acting per unit area. P is equals to F by A, where P is equals to the pressure, F is equals to the force, A is equals to the area. The hydrostatic pressure or the pressure of a liquid or a gas, pressure is equals to the H rho G, where P is equals to the pressure, H is equals to the height, and rho is equals to the density, and G is equals to the gravitational field strength. Pressure is equals to H rho G. This height means the depth of the liquid above the point of the observation. In a hydraulic press, Fx multiply dx is equals to Fy multiply dy, where F is equals to the force exerted on the piston and d is the distance moved by the piston. Chapter number 8. Temperature refers to how cold or how hot or cold an object is. Heat refers to the amount of thermal energy that is being transferred from a hotter to a colder region. The ice point is the temperature of pure melting ice at 1 atmosphere and is assigned a value of 0 degree centigrade. The steam point is the temperature of the steam from water boiling at 1 atmosphere and is assigned a value of 100 degrees centigrade. General equation for the Celsius scale: theta is equals to x theta minus x naught divided by x 100 minus x naught multiply 100, where theta is equals to the unknown temperature and x is the value of the physical quantity which will be changing with the change in the temperature. Chapter number 9. Kinetic model of the matter states that the tiny particles that make up matter are always in continuous random motion. The pressure P of a fixed mass of gas is directly proportional to its temperature T, provided its volume remains constant. In symbols, we can express this relationship as pressure is proportional to T. The pressure P of a fixed mass of gas is inversely proportional to its volume V, provided its temperature remains constant. In symbols, we can express this relationship as P is proportional to 1 by V, or P is equals to K by V, where K is a constant. The volume V of a fixed mass of a gas is directly proportional to its temperature T, provided its pressure remains constant. In symbols, we can express this relationship as V proportional to T. Thermal energy always flows from a region of higher temperature to a region of lower temperature. Net flow of thermal energy occurs only when there is a difference in temperature. Conduction is the transfer of thermal energy through a medium without any flow of the medium. Convection is the transfer of thermal energy by means of convection currents in a fluid, which means liquid or gas, due to a difference in density. Radiation is the transfer of thermal energy in the form of electromagnetic waves, such as infrared radiation, without the aid of any medium. Chapter number 11. Heat capacity. C is the amount of thermal energy required to raise the temperature of a substance by 1 Kelvin or by 1 degree centigrade. The heat capacity is represented with the capital C, and the capital C, the heat capacity, is equals to the Q divided by delta theta, where the Q is the thermal energy required and delta theta is the change in the temperature. Specific heat capacity C is defined as the amount of thermal energy required to raise the temperature of a unit mass, for example 1 kg of a substance, by 1 Kelvin or 1 degree centigrade. The small c, the specific heat capacity, is represented with the small c, and that is equals to the capital C, the heat capacity, divided by the m, or it is 1 by m into Q divided by delta theta, where C is the heat capacity, Q is the thermal energy required, delta theta is the temperature change, and m is equals to the mass of the substance. Latent heat is the energy released or absorbed by a substance during a change of state without a change in its temperature. Latent heat of fusion, LF, is the amount of thermal energy required to change a substance from a solid state to a liquid state without change in temperature. Specific latent heat of fusion, LF, of a substance is the amount of thermal energy required to change a unit mass, for example 1 kg, of the substance from solid state to liquid state without a change in temperature. LF, the latent heat of fusion, is equals to the small LF multiply M, where where the capital LF is the latent heat of fusion, small LF is the specific latent heat of fusion, and M is the mass of the substance. Latent heat of vaporization, capital LV, is the amount of thermal energy required to change a substance from liquid state to gaseous state without a change in temperature. Specific latent heat of vaporization, LV, small lv, of a substance is the amount of thermal energy required to change a unit mass, for example 1 kg, of the substance from liquid state to gaseous state without a change in temperature. So capital LV is equals to small lv multiply M, where LV is equals to the latent heat of vaporization, LV is specific latent heat of vaporization, and M is the mass of the substance. Then we have chapter number 12, the first law of reflection. States that the incident ray, reflected ray, and the normal at the point of incidence all lie in the same plane. The second law of reflection states that the angle of incidence I is equals to the angle of reflection R, means angle I equals to angle R. Refraction is the bending of light as light passes from one optical medium to another. The first law of refraction states that the incident ray, the normal, and the refracted ray all lie in the same plane. The second law of refraction states that for two given media, the ratio of the sine of the angle of incidence to the sine of the angle of refraction R is a constant. Sine I by sine R is equals to constant. This is also known as Snell's law. Refractive index of an optical medium N is equals to C by V, where C is the speed of the light in vacuum and V is the speed of light in the medium. N is also equals to sine I by sine R, where I is the angle of incidence in the vacuum and R is the angle of refraction in the medium. The critical angle C is defined as the angle of incidence in an optically denser medium, for which the angle of refraction in the optically less dense medium is 90 degree. The total internal reflection is the complete reflection of a light ray inside an optically denser medium at its boundary with an optically less dense medium. Relationship between the critical angle small c and the refractive index n of an optical medium is sine of the critical angle is equals to 1 by n. Focal length is the distance between the optical center and the focal point. Chapter number 13. It is about the source of a wave is a vibration or an oscillation. Waves transfer energy from one point to another without transferring the medium. The transverse waves are waves that travel perpendicular to the direction of the vibration. Longitudinal waves are the waves that travel parallel to the direction of the vibration. The amplitude A of a wave is the maximum displacement of a point from its rest position. Wavelength lambda, the symbol is lambda, of a wave is the shortest distance between any 2 points in phase. The period capital T of a wave is the time taken to produce one complete wave. The frequency f of a wave is the number of complete waves produced per second. The f is equals to 1 by t, where f is the frequency and t is the period. The wave speed is v is the distance traveled by a wave per second, Wave speed is given by V is equals to F lambda, V is equals to lambda by T, where V is the wave speed, lambda is the wavelength, and T is the time period. Wave speed is equals to F multiply wavelength. And a wavefront is an imaginary line on a wave that joins all the adjacent points that are in the phase. Chapter number 15, sound is a form of energy that is transferred from one point to another as a longitudinal wave. An echo is the repetition of a sound due to the reflection of the sound. Ultrasound is sound with frequencies above the upper limit of the human range of audibility. Pitch is related to the frequency of a sound wave. The higher the frequency, the higher the pitch. Loudness is related to the amplitude of a sound wave. The larger the amplitude, the louder the sound. Chapter number 16, electric force is an electric force is the attractive or repulsive force that electric charges exert on one another. An electric field is a region in which an electric charge experiences an electric force. The direction of an electric field is the direction of the force that would act on a small positive charge. The strength of an electric field is indicated by how close the field lines are to one another. Chapter number 17. Conventional current is in the opposite direction to electron flow. And the conventional current is from positive to negative, and that is due to the flow of the positive charges. And an electric current I is the rate of flow of electric charge Q. I is equals to Q divided by T, where I is equals to current, Q is equals to the charge, T is equals to the time taken. The electromotive force EMF of an electric energy source is the work done by the source in driving a unit charge around a complete circuit. E is equals to W by Q, where E is equals to the EMF of the electric energy source, W is equals to the work done, that is the amount of non-electric energy converted to electric energy, and Q is equals to the amount of the charge. When the cells are arranged in series, the resultant EMF is the sum of all the EMF of the cells. When cells of equal EMF are arranged in parallel, the resultant EMF is equal to that of a single cell. The potential difference across a component in an electric circuit is the work done to drive a unit charge through the component. Here V is equals to W by Q, where V is the potential difference or voltage across a component. W is equals to the work done, that is the amount of electric energy converted to other form. Q is the amount of charge. So the resistance R of a component is the ratio of the potential difference V across it to the current I flowing through it. R is equals to V by I, where R is the resistance of the component, V is the potential difference across the component, and I is the current flowing through the component. Ohm's law states that the current passing through a metallic conductor is directly proportional to the potential difference across it, provided that the physical conditions such as temperature remains constant. I is proportional to V, where I is equal to the current and V is the potential difference. V divided by I is equals to R, and that remains constant. The resistance of a metallic conductor, ohmic or non-ohmic, for example, filament lamp, generally increases with increasing temperature. R is equals to rho L by A, where R is the resistance of the wire, rho a constant, this is called resistivity, a fixed property of the wire's material. L is the length of the wire and A is the cross-sectional area of the wire. Chapter number 18. In a series circuit, the current at every point is the same. In a series circuit, the sum of the potential difference across each component is equal to the potential difference across the whole circuit. VE is equal to V1 plus V2 plus V3 plus and up to Vn. In a series circuit, the effective resistance is the sum of all the resistances. So the R is equals to R1 plus R2 plus so on plus Rn. In a parallel circuit, the sum of the individual currents in each the parallel branches is equal to the main current flowing into or out of the parallel branches. I is equal to I1 plus I2 plus In. In a parallel circuit, the potential difference across separate parallel branches is the same. The reciprocal of the effective resistance of resistors in parallel 1 by R is equal to the sum of the reciprocal of all the individual resistances. So 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by Rn. The potential divider is a line of resistors connected in series. It is used to provide a fraction of the voltage of a source to another part of the circuit. Input transducers are the electric devices that convert the non-electric energy to electric energy. Chapter number 19. For a resistor with resistance R, the rate at which the electric energy is converted to thermal energy, that is the power, can be calculated using any of these equations. The most famous equation is P is equals to VI, or the P is equals to I square R, since V is equals to IR, or it is the power is equals to V square divided by R, since I is equals to V by R. For a resistor of resistance R, the electric energy converted to thermal energy can be calculated from any of the following equations. E is equals to VIT. E is equals to I square RT, since V is equals to IR, or the energy is equals to V square T divided by R. Chapter number 20. Magnetic materials are materials that can be attracted to a magnet. Non-magnetic materials are materials that cannot be attracted to a magnet. Magnetic induction is the process whereby an object made of a magnetic material becomes a magnet when it is near or in contact with a magnet. A magnetic field is the region surrounding a magnet in which a body of magnetic material experiences a magnetic force. So we have then the chapter number 21. It says a current carrying conductor produces a magnetic field around it. The direction of the magnetic field of a current carrying wire is reversed when the direction of the current is reversed. The strength of the magnetic field of a current carrying wire increases when the current is increased. The strength of the magnetic field of a flat coil can be increased by increasing the current flowing through the coil. The magnetic field strength in a solenoid can be increased by increasing the current flowing through the solenoid, increasing the number of turns per unit length of the solenoid, placing a soft iron core within the solenoid. When a current carrying conductor is placed in a magnetic field, the conductor experiences a force. This effect of the conductor is called the motor effect. The direction of the force on a current carrying conductor is reversed when we reverse the direction of the current or magnetic field. The force, current, and magnetic field are at right angles to one another. The direction of the force acting on a current carrying conductor in a magnetic field can be deducted using Fleming's left hand rule. Conductors carrying current in opposite direction repel. Conductors carrying currents in the same direction attract. The direction of the force on a beam of charged particle is reversed when we reverse the direction of the current or if the particles are oppositely charged. The direction of the force on a beam of charged particles is reversed when we reverse the direction of the magnetic field. The turning effect on a current carrying wire or coil can be increased by increasing the number of turns in the wire coil, current in the wire coil. The turning effect on a current carrying coil in a DC motor can be increased. Inserting a soft iron core into the coil, increasing the number of turns in the coil, increasing the current in the coil. Chapter number 22, Electromagnetic induction is the process through which an induced EMF is produced in a conductor due to a changing magnetic field. Faraday's law of electromagnetic induction states that the magnitude of the induced EMF in a circuit is directly proportional to the rate of change of magnetic flux in the circuit. Lenz's law states that the direction of the induced EMF and hence the induced current in a closed circuit is always such that its magnetic effect opposes the motion or change producing it. An alternating current generator is a mechanical device that uses electromagnetic induction to convert the mechanical energy into electric energy. A transformer is a device that can change a high alternating voltage at low current to a low alternating voltage at high current or vice versa. The voltages and the number of turns in the primary and secondary coil in a transformer are related by this formula. Vs divided by Vp is equal to Ns by Np, where Vs is the secondary output voltage, Vp is the primary input voltage, Ns is the number of turns in the secondary coil, and Np is the number of the turns in the primary coil. So Ns is the number of turns in the secondary coil, Np is the number of turns in the primary coil. In an ideal transformer, the power supplied to the primary coil is fully transferred to the secondary coil. Vp Ip is equals to Vs Is, where the Vs is the secondary output voltage, Vp is the primary input voltage, Is is the current in the secondary coil, and Ip is the current in the primary coil. The efficiency of a transformer can be calculated using the following equation. Efficiency is equals to the output power divided by the input power multiplied 100. The number of complete cycles displayed on a CRO is given by the ratio Fy divided by Fx, where Fy is the frequency of the alternating current input and Fx is the frequency of the time base. So, my dear students, we have completed that quick revision from the book Physics Matters. The book I was using is Physics Matter, its fourth edition, and I hope that this video will help you and it will help you to revise your course quickly, and it will also help you to do revision and get good grades. If you find this video interesting and useful, please share the link of this video onto your Facebook, onto your Twitter account, and onto your Instagram, because when you do this, this helps me to promote my channel. I think it's a great blessing for me that I can make these videos and I can share it with the students around the globe and make their lives a little easier. Thank you very much, everyone. Have a good day, and God bless you all.